Hi, so I want to go the first part of the Krebs cycle. And sorry this took so long to do. My personal capture was broken for a long time, and they finally figured out how to fix it. Anyway, so the first thing we're going to do is form the acetyl-CoA. So it's the coenzyme here. And this is basically the starting material for the Krebs cycle, and it's this part right here. So before we can even begin, oops, missing an R there. We need to form this. Okay, so this will be the mechanism I do for today. Okay, so first let's start out over here. Now, where do you see these functional groups? This is a generic functional group here. Really what you should see is like an R group here where the CH3 is, meaning it could be attached to anything. This functional group is found in organic fuels. So that'd be your food, like fats, amino acids, glucose, all of those, your sugars. This functional group right here is found in all of those. So basically what we're going to do is this here TPP, thiamine prophate, right here, TPP, this basically an enzyme here, is going to break down your food. And so part of the Krebs cycle to make energy. So the first part to break it down is to attach to it. Okay, so this is a negative charge here, and here's some lone pairs. It's going to make a bond right here. Why here and not over here? Because there's a negative charge here, and these are electrons. These already have negative charges. They want to move away from it. So they're going to choose, this is called a carbonyl. Carbonyl is a very good bond, I guess, to attack if you want these electrons to attack. Why? Because oxygen is very electronegative, which makes carbon very electropositive. So think negative to positive, okay? So when this happens, these electrons go up, okay? Because if I don't let those go up, there'll be too many bonds to carbon. So when I do that, this creates this right here. Now let me show you. This here is the top part. Oh, and then also, there's always acids in your body. So basically what happens here is this oxygen will end up grabbing a hydrogen, so it'll become OH, okay? So it won't have a negative charge. It neutralizes everything. Okay, so this is what we have. This part here, this top part here, notice it's the same as this top part right here. So you have CH3, C, and this oxygen becomes an OH, so COH, C double bond O, O, C double bond O, O. Okay, so this is just the group at the top listed, and this is just the bottom. So all we did was attach them there. Now, you see in the next step, we're going to release CO2. Here is your CO2 right here. This is what's going to be released. Now let me change my color since I have a lot of green on here now. Now what's going to happen, I have these this negative charge here, and I want to get rid of it. I want to neutralize it. So basically what I do is I move these over, and that's too many bonds to oxygen. So it's this whole flow of electrons. So then the double bond here will move to lone pairs to the oxygen, and then basically what happens is these lone pairs are going to move down here, and what's going to then happen is then that bond will end up breaking. These will move to, here, and then which will move it to down here. So long story short, you have a flow of electrons here, and you can follow that if you want, but basically what happens is this bond breaks here, and this causes this bond basically will break and cause the electrons to move right here. So when that happens, do you see there's a COO, which is CO2. CO2 leaves from here. It's the leaving group, okay? And what you've created now, since this leaves, now we just have CH3OH here, and the double bond. You see, this bond is moving between carbon and carbon, put a dotted line there, making a double bond here. And this is your acetyl-CoA. So this is your coenzyme here. This is the first part of breaking your food down, okay, to form this structure here. And all we did is attach these two things together and make CO2 leave. Okay, this group here, this TPP, which is right here, is a great group to allow this carbon-carbon bond to break. Normally that won't happen. It's hard to break a carbon-carbon bond, but what's pulling it, oh, and let me also, oops, I forgot to put this, there's maybe too many bonds to carbon if I didn't move that over. What's pulling it is this positive charge on nitrogen. Okay, it's pulling these electrons toward, it's withdrawing, if you want. Withdrawing all of these, see this negative charge? Think of it as a magnet. It's withdrawing, it's making the electrons go towards it, okay? It's attracting the electrons towards this positive charge to neutralize it, allowing you to break that carbon-carbon bond, okay? So this is the first part. This actually isn't in the Krebs cycle. This is just to begin the Krebs cycle, okay? So I hope this helps, and we'll go over more. Probably tomorrow I'll make another video for you.